My name is Ciprian-Florin, and this is a demonstration of all the different modules that have been built in my ROS project. So first of all, we can start by going to the actual package itself, which is Assessment Mobile Robots 2022. And then in the launch file, we have multiple files that we can use in order to launch different modules. So let's start by launching the Telop Drive module, just to show how everything is. So ROS launch, Mobile Robots, Telop Drive. We'll launch this. This will be launched with RViz and Gazebo at the same time, as well as computer vision. So here I have the assessment world with the different boxes. I have the two OpenCV outputs. One is the regular output from the camera with the added information, and then this one is the mask. Here I have my robot in RViz with all the transfer frames. So it has a manipulator arm, the camera, a LiDAR, an IMU in order to create maps using hector mapping and RFD localization, and then 8 wheels. And if we go back here, since we have launched the Teleop, by just clicking into the command prompt, I can use I, JKL, M, dot, and comma to control my robot, as you can see. So I can control my robot, and it moves around. Side of this, let's try to go forward here and then stop. Now, if I look towards the box here, you can also see the control computer vision. So you can see how the box has been identified, and it tells me the area. And based on this area, I can enable and activate other modules that can do other things. For example, I can run a node that will move the robot arm to a different position, to a set position. Let's close everything now. Let's run the interface controller for the driver. So once everything closes, okay, just wait for the controllers to stop. We can run the GUI drive.launch. All right, now if we do the same thing, but with, we now have the same settings, pretty much same configuration with the OpenCV and the Gazebo, which can be disabled, but since we're using manual control, it's good to see where we are going. So here I can control it. So I can tell it to go to the left, forward a bit. Forward again. We can just move around by using this RQT controller for robot steering. And as before, you can see here on the left side, you can see the let's move a bit faster and then stop. I'm going to stop now. You can see the box that is identified from very far away. You can identify from any other point on the map if it's not behind the wall. Outside of this, I can also run by going into the command prompt or the terminal and running RQT. I can then run a plugin for joint trajectory controller, and I can select the control manager and then the arm controller, claw controller, gripper. So I can select that, run, and now have manual wheel control and manual manipulate arm control. So now that I'm zoomed in, and I go here, you can see how if I move this, drop time goes lower, it goes higher. And then I have another joint here, prismatic joint. I also have this joint here, which moves it higher and lower. and then the last joint, which changes the end where the claw is. So technically, by just going forward like this, I can then pick up a box that's in front of me by doing something like that. I can also go to the claw controller, which will pretty much extend the claw. This has been made in order to be able to pick up boxes that are smaller and larger, considering that there are 3 dimensions. So we can go from this to fully extended, which should be around here. And then we have the gripper controller, which pretty much changes the angle of the grippers at the end. Now I will show you how this robot can pick a box thanks to the gazebo grasping tag. And then after you pick the box, it can then be moved to any other place on the map. It is important to note that once the grippers make contact with the box, the robot has to stay still for 20 seconds, which is already included in a node that has been developed in order to control the arm from from either a Python script or from recalling it, importing it as a module. So if I go to the joint command here, this is the file, the script that has everything in order to move it, as well as different values for the big cube, the medium cube, and the small cube, and then 2 different ways of achieving the same, I would say, animation or tasks. Then I also have the different default positions for low, medium, high positions, open and closed, for the grippers, for the claws, smaller, larger, so far and so on, with all the different topics in order to publish on and the joints defined. So if I go to my terminal, which is here, and let's close Qt for a second here. Let's say I ROS run assessment and then joint command. Once I run it, the robot arm, you can see it is completing a certain list of movements. Now that this is the part where it grasps the box, you'll stay here for 20 seconds and then you'll move the arm up. By going into the script file itself, everything can be changed. So let's move everything here a bit to right. So we can just simply call the exact sequence that we want if we don't want to go with the list of lists and the for loop. So we can have all the different definitions that, and if we call definition with either low, medium, or high, then that will happen. So you can see how the animation happened there. Now I will show you how the grasping the box and moving it to the origin, but with manual control works. Now for the last part, I'll show you how the navigation works. So if I ROS launch and go into my package, and then from there I run the navigation stack, it will launch RVs and the 2 camera views. And then the robot has, with a navigation stack, we can just simply set a navigation goal and the robot will move towards it. Then we can also run the move origin script, which will move the robot back to its origin, or we can run the grid search, which will just go through different waypoints and then delete the waypoints that have been already completed. So you can see here, you can see the box and the mask of the box compared to the rest of the gazebo world and how it reached the goal that has been set. Furthermore, I will also add a video that will be sped up of the robot completing the grid search and going to all the points on the map. So pretty much completing a whole grid array of the entire map. Furthermore, if we go into the launch files and we change from OpenCV box check to OpenCV v2, so for example, launch file, let's choose the GUI one, and here we have OpenCV. Rather than OpenCV, let's do OpenCV v2. And now, if I run the code and I open everything, start everything, I have loaded the v2 of the OpenCV. So I have both cameras here. So the thing with the v2 is that it knows, based on the area, the difference between the different sizes of the boxes. However, there are some caveats because the area would change from further away. So this would have to be done in combination with other feature extraction used in order to have an accurate output. So now I'm in front of the big box. You can see the mask here. And then if I go to the actual camera view, you can see how this is a big box, has been identified as a big box. If we then move this away from it, I can then go and move the medium box from here to here. So we put in the sizing for the sizing for the arm controller to go down and pick it up. So you can see it is a medium box. And then if I go with the smallest one, which is right here, let's try and pick it up. Let's move this away. Then let's get this in here. You can see how it's identified as this small box, and normally it would be around here. And you can see how all the three boxes have different areas and they are identified differently. I'll also add some screenshot of the robot arm being able to pick up all the boxes, as well as the video of the robot completing the patrol with the grid search. With all this said, I would like to thank you for the time dedicated.